Hey everyone, welcome back to my channel. Let's solve some LeetCode today. The problem for today's video is degree of an array. So we are given non-empty array of non-negative integers, nums. The degree of this array is defined as the maximum frequency of any one of its elements. Your task is to find the smallest possible length of contiguous subarray of nums that has the same degree as nums. So an array, we're given an array, so it has a degree. How do we calculate its degree? So we have frequencies, right? So we have the number 1 has occurred 2 times, the number 2 has occurred 2 times, number 3 has occurred only single time. Then we need to take the maximum values of this maximum frequency. So in this case we have 2 max frequencies, so the degree of nums is maximum frequencies of any characters. So now we need to find a length of subarray that has same degree as nums, but that subarray should be the minimum possible. For example, in this case, so we have this array, it has degree 2, and we have this array, and this has also degree 2, and we have this array, this has degree 2, and we have this array, subarray, that has degree equal to 2. So in this case, the minimum subarray is degree 2 is 2. So in this case, we are going to return 2, which is length of minimum subarray possible is the same degree. So in example number 2, we have this input. In the frequency, we have 2 ones, we have 3 twos, we have, how many 3s do we have? It's 1 and 1, 4. So we have this frequency, so degree of nums is equal to 3. Which number is defining this? Number 2. So this is our value that is defining the degree of an array. So here this array has degree number 3, and this array has number degree equal to 2, because we are just removing 1 2, that frequency will decrease, so we cannot do this because, and this specific subarray has degree equal to 3, and this is our answer. So the length of this array is 6. We cannot shrink it anymore, so result is equal to 6. So how do we approach this? How do we solve this problem? So approach number 1 is using 2 pointers and shrinking until we have same degree. So in this case, we are going to take this input and try to shrink it. So we shrink it, calculate the degree, it's still 2. We shrink it again, and we calculate the degree of this subarray, it's still 2. So we try to shrink this. Now this time we get degree equal to 1, so which we don't really want to have. So we did maximum shrinking from the right side, and now we start shrinking the left side. So we remove the first element, so left pointer will be on right, one element right from its old position. So we have double 2's, and the degree is still 2, so we are going to we try to shrink it. So now we have degree of 1, so we cannot, that means we cannot shrink left side. So that means the length of final output with minimum number of elements but with the same degree is 2. So the time, let's analyze the time and space complexities. Time complexity would be O of n, and space complexity would be O of n as well, because we are using counter and we are shrinking and calculating the counter again. Or we can just, once we shrink, then we can just remove the element from the counter. We can decrement it. So this is the time and space complexities. And second approach is finding elements that defines finding the elements that defines degree of nums and maximum, subtracting maximum index and minimum index and get the minimum result. So max index and min index. So we calculate all of this maximum and minimum indexes and find the minimum in this range. So the time complexity would be O of n, and space complexity of this solution would be O of n as well, because we are using the counter and we have pretty huge range, so the counter can get very huge. So let's implement first approach using pointers. So let's use counter first. Count array elements in nums. So we have them right now, and initialize left and right pointers. So left is on the left and right is on very right of nums, on the last index of nums array, -1. So let's find first degree of degree is equal to maximum of counter keys, right? So this keys gives us the keys. The keys represent the frequency of each element, and we find max here. So on first step, shrink right side. So while true, we'll introduce the condition later. So while true, right minus equal to 1, so the element on the right, so nums right, this gives us the element that is located on index right, and we are going to go to the counter and take it. And decrement it. And then calculate the degree here. This is a new one. If new degree is less than degree, we can break this loop. But just before this, we need to increase the counter back to its original position. So with this, we have shrink the right side. So in the second step, we are going to shrink left side while true. Let's copy and paste it. So this time we are going to use left side. So we are going to shrink the counter, and counters left would be +1 in case we break just before breaking. And then we are going to move left to the next position, and our result will be right minus left and +1. So this is our solution. So let's run it. Index out of range. So what happened? What happened? So nums array, why it is happening? List out index out of range. So we have right pointer. It's on the latest index. And we are making it smaller, smaller, smaller on each iteration of this while loop. So this will be a very good postmortem if we find the issue here. So we have right, initialize it as the last index. For example, in this case, 0, 1, 2, 3, 4. It would be equal to 4. But why it's saying it's out of range? So here is our num. And let's use num here as well. And here as well. So while true, we're taking the num. On first iteration, it will be the latest element. And we are going to remove it. Okay. So this condition is never met. Why? Because no, actually we are showing decrementing the counter here, so it should work. It will calculate the new degree here, while right is bigger than -1, and while left is smaller than length of nums. So to be clear, let's move this to num variable as well. So num let's give it a try. So output was -5. Okay, right minus left. Why is that happening? Actually, it's tempting to print everything in debug, and we're not going to do this. We're going to do debugging ourselves. So you're removing, subtracting 1 from counter's depth key and calculating a new degree. If new degree is smaller than actual degree, then we are just undoing our operation and breaking the loop. Otherwise, if it is not, the new degree is not smaller than the degree, then we are just subtracting 1 from our right pointer. So next time we are going to work with the element that's coming before, with 3, right? And why it's not working? So, and finally, it's going to give us the pointer, like indices, that we should be able to subtract and get the values. But why in these cases it's has strong output? Okay, maybe the so let's open our Python interpreter. From collections, import counter. So we have counter is equal to counter 1 2 2 3 1 is equal to that, and Okay, it's working. If we do something like this, then it's equal to 0. If we do one more time, then it is -2. It's working. It's mutable. So print right here, print left in here, just to have debug info. I think it will help, but why don't we have our I think this condition is not being matched, so new degree, let's print our new degree. I think it's not being updated. Yep, and degree is being calculated as 3. Do we actually have correct logic to... Oh, we need to get values here. Values, values. Now this should work. It's a single typo. Have missed it and spent some time for debugging. So what's happening here? Let's use a test case and do this by ourselves. So we have 2 in here. Let's use counter here. Counter c is equal to z, and we have degree of 5. So the numbers that are defining our degree is 3 and 1, not 2. That means we can shrink it here. Even if we shrink here, it's still the same degree. Yeah, we are shrinking, so this solution does not work because we are shrinking from the right side, beginning from the right side. Like if we do the same logic and shrink the left side first, it works, but some other test cases will fail, I'm sure. So let's give this a try. Test case 3 will succeed and other test cases will break, most probably. So yep, it doesn't work. Okay, so in this case we are not going to use 2 pointers because they are biased. Let's use different approach. So we are going to find So let's remove this. We have counter here for num and its frequency in counter max frequency is, let's say, 1 for now. Okay, doesn't matter to be 1 or 0. So let's first find maximum degree. Degree is max, counters values. If frequency is equal to degree, then leaders, let's say leaders, we have, if frequency is equal to degree of an array, then we are going to add those numbers to our leaders array. Leaders will be added num. And now we are going to find the first and last index of each of these leaders. So for I in length of nums, so leaders, let's make it dictionary. Leaders num is equal to empty list. If so, it's enumerate and num. If num in nums, okay, it's already in nums. Num in leaders. Then what we are going to do, leaders num so if it is not empty, then what we can do, we can append leaders so let's add zeros here. So okay, let's use -1 and -1 here. If number is on leaders, then num first value is not equal to -1, we can say leaders num 0 is equal to I. Else, if we have already initialized the first index, then we can say that we update the second element only, just 1 to be I, and we go through the leaders. So minimum is length of nums 4. So we have begin, start, and end in leaders dot values. If end minus start plus 1 is less than minimum, our new minimum is that. Or actually, okay, let's do this manually. And we are going to return minimum value. So we are going to have syntax errors here. Just we need to look and find them. Num and frequency in counter dot items. So yeah, we found one of them. Frequency and degree. If frequency is equal to general degree of array, then okay, we are going to initialize leaders. If number is on leaders, and we are going to find first and last indices of leaders, that leader number, and we are going to iterate through leaders. So it has values. Each value has 2 elements, so we can unpack them to start and end. So in this case, this should work. Let me submit the solution. Counters, so name error. Where? Line number 32, counters. So it's actually counter. It's a typo. It's going to work. Oh, it's not. Output is 0. And why is that? We have forgot to add this case. Okay, let's use this test case. I thought this would solve the issue. So we have one number in nums. Frequency degree is 1. Frequency of that number is 1. So we have leader. Okay. Let's make this 0 because we are checking for the first index only to be -1. So it indicates that we haven't touched the first index, we haven't updated it. So we don't really care about the second index. We update it to be the last index. So this is our last chance, actually. One more problem here. So why this keeps happening? This keeps happening. Nums 2 and 1. How it's working? So we have leaders. So both of these numbers are leaders. Or actually, let's initialize the first index as well here and use the test case. This time it should work. No, it's not working. So output is 2 now. We have the same index, 0 minus 0, and it will be, it should be 1. So where exactly it's broken? Let's minimize this, not in leaders. We can continue in this case. And then make it like this. Minimize this as well. Minimum is length of nums. Now we don't have end and start, so if we remove this condition, we don't need to check. So this time it works. Why it was not working? Because end and start can be in the same index if the degree of an array is equal to 1. And here we are updating the both indices. Because of that, it is going to be the same in certain cases. So this is our solution. So how many lines is that? So this is roughly 20 lines. So it might not be the most elegant one when it comes to code. So we have 3, 4 loops. Maybe there is much simpler way of finding this and solving this. But anyways, we have provide multiple approach and have seen that this two pointers approach does not work because it's biased. If we shrink the left side first, then we are going to miss the case where the shortest path on the left side. If we start shrinking from the right side, then we miss the case where the shortest subarray is on the left side. So despite it is not going to work until we add even more test like cases, checks, conditions. So then we move to the implementation of this second one, where we find indices of leader numbers and find the minimum by subtracting those indices. So thanks for watching. See you in the next videos.